Hello everyone, I hope you are all doing well. My name is Deepak Gupta and today I will be presenting our work on a unified framework for multilingual and code mix visual question answering. This is a joint work with Pavitra Lenka, Dr. Asif Iqbal and Professor Pushpak Bhattacharya. In this presentation, I will begin by providing introduction to visual question answering in multilingual and code mix environment, followed by some motivating examples. Later, I will discuss our method for the creation of MCVQ datasets. Then I will discuss the proposed approach. Finally, I will conclude with the experimental result and analysis. Starting with introduction, in this slide, as you can see, the politicians across the world often tweets in multiple language to broadcast their messages. This phenomenon of using multiple language is known as multilingualism. These tweets are multilingual. People tend to use multilingual to connect with the people of different spoken languages. The challenges of multilingualism can be understood by the fact that Hawaiians have over 200 different words for the words rain, and in Indonesian, air stands for water. Multilingualism is widely observed on the various society across the globe, specifically in the communities where the people tend to communicate in multiple languages like India and Singapore. I will briefly define code mixing with an example here. Code mixing is another dimension of multilingualism where people mixed script of multiple language to express themselves. For example, the example sentence here USA के foreign secretary कौन है is a code mix sentence. Here USA foreign and secretary are the English word and key कौन and है are Hindi words. The structure of sentence follow the Hindi syntax and English words are mixed here. Uh, there are some reasons for code mixing. The first is it is used to speed up the communications process when someone knows that the other persons to whom he or she is speaking with understand the multiple languages. It is also used to express better and wider. Example: politician and celebrity tweets in multiple language for wider accessibility. I would like to define the task here. We are witnessing a renewed excitement in multidisciplinary research problem focused on computer vision, NLP, and knowledge representation and reasoning. Towards this, we study and propose the task of multilingual and code mix visual question answering, which is another dimensions of the question answering. I will discuss the task by considering various cases. In case one, an English question and image given an English question and image, the visual question answering system takes the input question and interact with the image and predict the answer. In this example, for the question what sport is the man playing, the visual question answering system should be able to predict the answer as tennis. In case 2, given a Hindi question and image, the visual question answering system takes the input question and interact with the image and predict the answer. Like in this example, the Hindi question is "Aadmi kya khel raha hai?" The translation is the same. What sport is the man playing? The visual question answering system should be able to predict the answer as tennis. And in the third and final case, given a code mix question and image, the visual question answering system should takes the input question and interact with the image and predict the answer. In this running example, the question is a code mix question which is "Aadmi kya sport khel raha hai?" with the same translation, "What sport is the man playing?" The visual question answering system should be able to predict the answer, the same which was earlier, the tennis. Okay, so overall, our problem statement states that given a multilingual question, English, Hindi, or English Hindi code mix question, and image system should process, understand, and predict the answer. Coming to the motivation, Google Assistant, Alexa, Siri, Cortana are virtual assistants that are on the market today. Perhaps you have asked your virtual assistant to tell you the weather, ask Google Translate to help you with your English poem, play the movie, schedule a meeting. All of those technology are applications of question answering system. Given their usefulness, yet in real life their applications are limited because of the incapability of handling multilingual and code mix question. Let us consider the examples shown here. Here I'm showing two examples which is taken from our work here. The majority of the recent state-of-the-art visual question answering model are capable enough to provide the correct answer when the user asks the question in English. But our study reveals that the same model could not predict the correct answer when the same question was asked in Hindi or English Hindi code mix. We utilize the visual question answering 1.0 dataset to build the counterpart multilingual and code mix visual question answering dataset. The visual question answering 1.0 dataset has the questions in English. We keep the answer same as was in visual question answering 1.0. To create Hindi question, first we translate the English question into Hindi using Google Translation. Thereafter, we use our earlier work to create the code mix question from translated Hindi question. According to the approach, given a Hindi sentence, first we get the part of speech and any add tags. As you can see in this example here, there are certain part of speech and any add tags which qualify to be translated and others will remain same in their corresponding transliteration. As you can see in this slide, the words Rajasthan corresponding part of speech NNP and Purana corresponding part of speech JJ, the adjective, and Sangrahala, these are the qualified word to be to get their correct transliteration. So we use a pre-trained SMT model to obtain the set of lexical translation for the qualified word. Thereafter, the best lexical translation is chosen to be the part of code mix sentence. We select the best translation candidate based on iterative disambiguation algorithm based on the co-occurrence matrix. To create MCVQA dataset, the created MCVQA dataset has around 248K and 121K Hindi and code mix question in training and validation set respectively. Here are some examples from our developed MCVQA dataset. Coming to the approach, our approach consists of first multilingual question encoding, which is a language agnostic question encoder. We build a hierarchical encoder with a CNN and two LSTM layer in order to process and encode the question with the particular treatment from different languages. We introduce layer attention. The layer attention provide a facility to control the behaviors of encoding layer while processing the question from different languages. I mean to say English, Hindi, and code mix. Second, to effectively to answer a question, we enhance the vision understanding by combining local image grid, which obtained from ResNet, and the object level feature obtained from RCNN. To fuse the question and image feature, we adopt the bilinear attention network. Finally, the answer prediction component predict the answer, which is a two-layer feed-forward network with ReLU and softmax activation function. Here is the architecture of our proposed approach with our running example. The question are encoded using the hierarchical language encoder, which when we apply layer attention weights on the output of CNN and LSTM encoder. We also use self attentions to identify the prominent question word. The image features are extracted from RCNN and ResNet network. The question image fusion network, which is a bilinear attention network, is used to fuse question and image feature. The fuse feature is used by MLP classifier to predict the probable answer. Coming to the result, we compare the performance of the proposed approach with the recent state of the art in visual question answering, such as MFB, MFH, bottom-up top-down attention, and bilinear attention network. Our unified visual question answering model achieved the state of the art performance on English, Hindi, and code mix visual question answering dataset. I mean to say visual question answering 1.0 and our created MCVQ dataset. We also perform additional experiment to analyze the performance of the best competitive model here, which is bilinear attention model on Hindi and code mix question. As we can see in table, the upper table, the model performs very well. Model performs very well on in-language training setup, but suffered in cross-lingual setup and shown poor performance across the different languages on each evaluation criteria, which is overall, other, number, and SNO. We also perform evaluation study to analyze the contribution of various components of our proposed system. Table shows the model performance by removing one component at a time. The self-attention on question and object level features seems to have maximum effect on the model performance. Coming to the analysis, we perform a thorough analysis of the error encountered by your proposed model on English visual question answering MCVQ dataset. We categorize the four major sources of error. The first is the semantic similarity. This errors occurs when an image can be interpreted in two different way based on the visual surrounding. In those scenario, our model sometimes predict the incorrect answer that is semantically closer to the ground truth answer. For example, in figure here in this figure, the second example, the question is where is the beer? Our model predict the forest as the answer. However, the ground truth answer is woods, which is semantically similar to the forest and is reasonable answer. The second error is ambiguity in object recognition. This error occurs when object of an image have similar object and image level feature. For example, in this example, the first image, first samples, the question is this a ram or a? Our model predicts sheep as the answer in all the three setup based on the ground truth answer is ram, but the ground truth answer is ram. Similarly, the third error is object detection at fine grain level. Error occurs when our model focus on the fine grained attribute of an image. The fourth type of error is cross-lingual training of object-level feature. Our proposed model has the capability to learn question feature across multiple languages. However, the object-level feature used in this work are trained on English language dataset, which is visual genome dataset. We observe the last sample in figure D that the model sometimes fails when the question is in English or Hindi. English or code mix. Concluding, we create a linguistically driven Hindi and English Hindi code mix visual question answering dataset. To the best of our knowledge, this is very first attempts towards this direction. We propose a unified neural model for multilingual and code mix visual question answering, which can predict answer of a multilingual or code mix question. In the future, we plan to explore transformer-based architecture for visual question answering in multilingual code mix setup, considering various diverse languages apart from English and Hindi. These are some references, and thank you for your